Hi, everyone. My name is Amir. I work at Capital One. We're based on Old Street. I'm going to be talking to you guys today about proxies, generators, and symbols in the real world. Why am I doing this talk? What's the purpose, really? We have a bunch of features in the language that don't get used that often. And that could be for various reasons. Maybe some people just don't have the time, or maybe they're more comfortable with what they know. Or in cases that people I often talk to is that they say, well, I don't know what to do with this in actual projects that I work on. So I figured, maybe I can do a talk on sort of real world usages, things that I've actually used these features for in my own projects. And hopefully that'll be useful for you guys. So yeah, demonstrate real world examples, actually show you the value that you get out of it. So it's not just about using these features for the sake of using them, but actually what's the point of doing that. And hopefully encourage you to explore the language more for sort of the lesser known features that are available to you. Some out of the box thinking. It's always interesting if you can take an existing problem that you've addressed it in a certain way and then you think, how can I kind of do this in another way, address it in a different way. Finally, just have a bit of fun. I don't know about you, but I quite like just discovering new things and just, see how I can kind of change the paradigm. So yeah, let's get into it. So this talk is actually going to be, for the most part, just looking at code. Now, I understand it's a lot of stuff. Don't worry if, at some point it becomes too much. I'm going to include a link at the end of the talk to the code examples, and feel free to just clone it, run it for yourself, see what you can do with it. Right, okay. So before I show you some examples, let's just start with generators, and just so everyone is sort of on the same level, I'm just going to quickly show what generators actually are, and then jump into an example. Generators are sort of these interesting functions that when you call them, they generate. Can anyone see that, by the way? Do you want me to zoom in a bit more? Is that all right? Okay, cool. So basically, when you call them, they generate sort of what's called a generator object, and this generator object has a next method on it. So every time you call next, it will start executing this function, and it will stop when it gets to a yield statement, and it will return that value. So if you keep calling it, it would sort of give you the next value, and so on and so forth, until it will basically finish, and then you're sort of done with the last value that you can get out of it. Another way of using generators is using the for of syntax. So in this case, you can kind of use it like this. So, quite handy. Where they're really powerful, I would say, is async generators. So async generators basically do the same thing, but they do them in an async fashion. Actually, before I do this, let me just define sleep. So sleep is just a utility function here that sleeps for a certain number of milliseconds. So now, if I run this async generator, so for the async generator, you need to use for wait, essentially. You can see there's a delay. So every 100 milliseconds, it will give you a result. You might also notice that you won't get the return value. You only get the yields. So there's a massive difference here. So make sure you don't rely on the return value here if you're going to use the for of version. So that's pretty much it. There's a lot more to it, and I would suggest you go and have a look, but that's kind of the gist of it. Now, where's this useful? So I had this case recently, actually not that recently, more like a year ago, where I needed to empty an S3 bucket on AWS. Now, the way you normally do it in using the SDK is you have to get, is that readable, by the way? Yeah, cool, nice one. All right, so the way you have to do it is that you can get a list of the objects, and then you have to sort of essentially loop over it and delete those objects. By default, I think the limit is 1,000 objects, if I remember correctly. So at any one time, you get a maximum of 1,000 objects. So if you have a massive bucket with loads of objects in it, and you want to empty that bucket, you have to get 1,000 at a time. And the problem is that every time you get a batch, it will give you the key for the next batch. So like say you get 1,000, it will give you the what's called a next key marker for the 1,001 object, and then 2,001 object, and so on and so forth. So you have to make them in sequence, essentially. So this is actually what generators are perfect for, because you can't do them in parallel. We have to do them in sequence. So I'm just going to wrap this API with a while loop, and until the next version is undefined, I'm just going to keep continuing this loop until basically there's nothing left in the bucket to be returned. So I'm just going to keep hitting it for me to get these things. And every time I hit it, I yield those items out. So this kind of makes reading items out of an AWS S3 bucket a lot easier. In fact, I'm kind of surprised that the library doesn't do this already, doesn't give you a generator, because generators are perfect for this. But then again, the library hasn't been updated, I think, since 2006 or 16 or something. So we'll probably be waiting for a while. And then let's have a quick look at this usage. So like I said, we can use for await. We get the objects out of this generator, and then we do the delete operations on it. So that delete operation itself is async, but I'm not awaiting it. And there's a major difference between awaiting inside of this for await versus this await that's here. The await that's here is waiting for this generator to yield. But if you do wait here, it won't continue to the next loop until it's finished. And I don't really want to wait for the deletion to complete to delete the next set of objects. I don't have to. Like, that's not necessary. I'm just going to slow myself down. So instead, I'm just going to push it into an array and do promise.all, essentially. So I'm just going to get the list of objects one at a time, pass it to my delete function, and just say, just store all these delete promises. And then when I've basically finished with all the objects, at the end, I'll wait for all of the deletions in one go. So it's just, you got to be careful when you do the await. So if you do it in a place that is unnecessary, you're just going to slow down your code. So that's one example of sort of a real life usage code that we actually use in our own pipeline. One thing though, unfortunately, I was going to do a demo for you guys to show you actually the objects being deleted, but I had some technical problems with my AWS account earlier. So I can't show you, but feel free to, like I said, clone this, give it your own test bucket, and it will work. 100% promise it will work. As long as you've set up the profile and everything, it'll do the job. Right, okay, so let's move on to the next one. So the next one I'm going to talk about is the proxies. Yeah, okay, cool. So again, I'm going to just quickly show everyone what proxies are. So proxies are sort of this way of intercepting operations on an object. So say, for instance, you got this object here. Now, every time somebody accesses a property, say you want to turn that property into a different kind of property, you want to like maybe return something else, So the way proxies work is you essentially have a bunch of handlers that you can pass. The first argument is the target object that you want to intercept operations on. And then the second argument is a set of handlers. So I'm not going to go through all the handlers because quite a lot of them. Like you can do anything from catching calls to the constructor, setting, getting, things that, for instance, how console log actually accesses things, which is the object get own values or something. I can't remember the actual API, but there's a lot of handlers that you can actually set. It's quite powerful. But in this case, all I'm doing is I'm putting a get handler. I'm saying whenever someone tries to access a property on this object, basically take that property, add 1, 2, 3 to it. So if I access a proxy, I'm like, I want to access hello. Instead of world, it would give me world 1, 2, 3. The big difference here, though, is that if I access the original object, that's still like it was before, because I'm not actually touching the original object. I'm just using the proxy. One thing, though, proxies are quite powerful, but it's also really easy to get them wrong. So for instance, in this case, I'm never checking to see if that property is a string I'm doing this thing to. I'm never checking if that property even exists. So if I do something like this, undefined 1, 2, 3. Not quite what I want, is it? So you got to be careful with them. And one more thing, you can only really use this on platforms that support it. So Node, for instance, Node 6 Plus, or anything that supports ES 2015 Plus on the browser side, because it needs engine support. It won't work otherwise. There's no way of Babeling this. So yeah, just a bit of a heads up on that end. So that's basically what proxies are. So again, this talk is about real-world examples. How did I use this? So we had this project a while back where basically it's this external system done by a certain company. I'm not going to name them. And basically, it handles our customer service agent calls. And every time the call comes in, it puts an account ID in some sort of nested property somewhere, somewhat similar to this thing that I've put here. A lot more nested than this, actually, but roughly this. And even though they were providing us with certain events, those events weren't reliable. They could still mutate that account ID at different times. And one option of getting that account ID was to poll for it, like every, I don't know, 100 milliseconds, check the value again, see if it's there or not. It's fine, it works, but a better way of doing it, if your platform supports it, is to use proxies. So one of the most probably popular ways of using proxies is using it for the observer pattern. So I wrote a little sort of a watch utility. So I'm saying, OK, I'm going to pass it an object. I'm going to put a set handler. So this is when you're setting a property. Then every time a property is being set, if it is equal to the property I'm looking for, then call my callback. Also, don't forget to actually set it, because if I don't set it, then nothing will happen. So, again, kind of straightforward. I'm just watching that property being set. And this is it being used, essentially. So I'm saying watch dialog.media.vars. I'm looking for account ID. And then make sure you call my callback here, which is console logging. And then down here, I'm trying 3 different set operations, 2 on account ID and 1 on test, a different thing. So let's just run this and see if it works. So, it works. It also doesn't give me test because that's not what I was looking for. You can write this utility however you want. Maybe you want to watch with multiple properties. It doesn't really matter. It's up to you how you write it. Now, you might notice we're using a callback here, and that kind of sounds a bit old-fashioned, at least to me. So I'm like, can I use generators for this, potentially? And the answer is yes, you can. You can use generators. However, using generators for things like this is a little bit more complicated. So the previous example where we used generators, it was sort of our choice to be like, I want to call the next operation. Here, it's sort of not our choice because this callback is going to happen by some other piece of code. The best way I could come up with, I'm kind of open to see what other people can come up with, but the best thing I could come up with is basically write a utility which basically I call async queue. I've included the code for async queue in this repo, which again I will link to, so feel free to go have a look. Probably won't have that much time to go over the code for it, but I'll just give you sort of overview of what it does. So it's a queue, like you would expect. Item comes in, an item goes out from the other end. And the async part of it is that it's also a generator at the same time. So once you start streaming it, essentially, using this for wait, it will empty the queue for you. So it will give you values. But if it's empty, then it will just wait. And it won't give you anything until something else comes in the queue. And then basically my callback, I'm just adding items into the queue. So I'm just adding items into the queue. From the other end, I'm emptying the queue. So yeah, that's that's sort of a way we can doing this. And let's run that. Let's run this one. See if it works. So this works as well. However, I'm using an async generator, right? But this is sync. Like every one of these set operations is happening one after another. Let's just give it a quick try. So I wrote another one where I'm like using set interval to just introduce a bit of a delay. Let's just see if that works. So we know that our async queue is actually async. It's not just async in name. So there is a 1 second delay, but works. So this set interval, all it's doing is essentially going through this array, and then it's just calling. It's changing the properties on the object one by one until it runs out, and then it kind of quits. So this pattern of turning multiple sort of invocations of a callback into a generator is, I would say, the best sort of use case for generators. So if you can imagine, a promise is sort of replacement for when you execute a callback once. A generator is when you execute a callback multiple times. It's the replacement for that, an async generator. And speaking of that, set interval is also a callback, isn't it? I'm not going to do it, but you can easily also turn set interval into an async generator. You might say, maybe this is taking it a little bit too far, but you can. I'm not saying maybe you should, but it's up to you. Like every API that you've seen out there that uses callbacks that get called multiple times throughout its lifetime can be turned into an async generator. And the value that you get out of this, to me personally, it's just it will make your code a lot easier to read. Without this, a lot of the times you can kind of get into a bit of a callback hell, or recursive functions that have to call each other depending on what sort of things that you're trying to do. You can use Babel for this, for generators and async generators. However, I would say if your platform supports it, that's better because it's faster. Just looking at what Babel does, what it generates, it's a bit big. It's a bit convoluted as well. But you can use Babel if your platform doesn't support it. Right, OK, cool. Finally, symbols, the last thing. So before I sort of mention what symbols actually are, let's just look at sort of the problem I had where I ended up using symbols for. So I had this thing where I needed to create a graph for one of our apps. And I sort of, something like this. I had like a node class, and it was like, I'm creating it, and I'm creating the values for the graph, and then I'm sort of using something like this to be like, all right, these are the relationships. So I got like a node A, and that's related to node B and C, and then I got node D, and that's related to node C, so on and so forth. It kind of works, and it's kind of fine, but I kind of hated the fact that I had to rely on these strings, because at least traditionally speaking, in objects in JavaScript, the keys are always strings. And it's easy to sort of make a mistake with these strings and create some sort of inconsistency, and have to make sure they match each other. So I was like, is there a better way of doing this? Is it possible for me to use the actual object as the key? And it is, basically. That's where symbols come in. Symbols are sort of these special objects, if you will, where basically, so this is how you initialize a symbol. The description, it actually doesn't really matter what you call it. It really doesn't. It's just for debuggability, essentially. So whenever you call the constructor, it will create a new symbol object. Now symbols are unique when they're created, except global symbols, which are kind of a different thing. So for instance, if I go back to the console, if I do symbol, let me just clear the console. If I do symbol, yeah, if I do this, even though they both have the same description, they're not equal. And the nice thing about symbols is that even though they're objects, you can actually use them as keys in other objects, essentially. And they will work perfectly fine. In fact, that's what they were built for anyway. So yeah, you kind of use symbols there, and it's kind of fine. But then after that, I was like, all right, so the whole point of me having objects is because I want to have properties on them. So I want to be able to put methods or other things on this node. But if you look at symbols for a second, say I got this symbol. Say I want to put hello world on it. If I try again to access the property that I supposedly set, it gives me undefined. So I didn't set it, which is a bit unfortunate because that was the whole point of me actually using symbols for that. But there's a way of doing it, and that's wrapping. Even though they're objects, they don't sort of expose their object nature, if you will, immediately. To be able to use them as an object, you have to wrap them in an object. So like this, essentially. You just wrap your symbol in an object. And now at this point, I can actually assign a property to it. And then if I check again, my property is there. And even more importantly, that object version will still be able to be used as a key inside another object. So it does kind of both things. Now, I should sort of say that I'm not 100% sure whether symbols were actually made for this very purpose. But it is possible to do them with them. There's a bunch of other stuff you can do with symbols, and also there are some built-in symbols into the language which are really powerful. And actually, I'm using one of them in the Async Q class that I mentioned earlier. You should totally go and check that out. And I'm actually probably going to publish that on NPM at some point, whenever I get a chance. Yeah, there's some really cool stuff you could do. You could like create sort of your own custom iterator, like your own custom collections, and do for of on them. You can sort of write, be able to use the instance of operator without actually using the class keyword. There's a whole lot of stuff you can do with them. They're really cool. Yeah. Okay. So just quickly showing you actually so this is the symbol being wrapped in an object. So I'm putting like first name, last name on it, and then I'm putting also like a getter on it for the full name. So just like any other object. Assigning a bunch of names to it. I'm console logging a full name. That's actually my name. Let's just run this one, see if it works. There we go. Yeah, it works. So just proving that it actually works. Right. Okay. Cool. So that's for my examples. Just in summary, some of the potential use cases. Actually, I shouldn't really say potential, but there are actual use cases you could do things with them. There could be a lot more than this, and which I haven't explored. I would totally encourage people to go out there and like find more use cases because it's cool. So proxies, you can reuse them as replacement for inheritance in classes. I'm not saying you should, but you can. So you can return a proxy from the constructor. And instead of using inheritance to sort of hook into other classes, you can actually proxy to their methods. And you can kind of pick which one of the methods you want to proxy to, for instance. So it's really sort of up to you how you want to do it. Maybe you want to do some sort of thing in the middle before you actually give access. We do something like this for our browser testing. So we sort of wrap the underlying elements that's exposed in our browser tests, our functional tests, and add our own kind of methods on top of it without actually ever touching the old thing. You can use them as observers. I think there are a few libraries out there that actually use proxies for this very purpose, observers. So it's like the biggest thing. And generally speaking, you can use them for all sorts of middleware. Anything that you just want to catch something in the middle of an operation, just do something with it. You can use them for that. Symbols, constants, essentially, sort of a better constant than a string. React pretty much uses it for that purpose, for React elements. There's a good article by Dan Abramov on his Overreacted blog where he talks about it, worth checking out. Metaprogramming, again, there's a really good article. If you just Google symbols, metaprogramming JavaScript, you'll find a really good article that covers all of it. And then finally, objects as keys. The most important thing of all this is, how you can use symbols instead of strings as your keys. Generators, so sequential async tasks. This was what I mentioned with AWS. So whenever you have an operation that happens one at a time, again, don't do it for parallel. If you have something that has to happen in parallel, don't use async generators. Use promise.all. And finally, converting old callback-based APIs to async queues. So that's sort of the other sort of option that I mentioned with async generators. As I mentioned, this is the link to the code examples. Feel free to check it out. Thank you.